Hi everyone. So what we're going to talk about today is area using integration. So we have two cases where there's only one curve or two curves. If you have only one curve, usually we'll talk about one curve with the x-axis. So it's usually like this. Let's say you have a curve, and then you're going to talk about between the curve and x-axis, which is here. Or with y-axis, so what you have is gonna be like this, and then a curve, and here is it, because it's between the y-axis and the curve. Alright, so the difference between these two is your area you're gonna have in terms of dx when you are going to refer to the x-axis, or dy when you're gonna have the area between the curve and the y-axis. For area between two curves, you don't have to bother about this that much because it's gonna be something like this. Alright, so what you have to do is you have to find the intersection point between these two. So if your intersection point is the x coordinate, then you're gonna have in terms of x, or vice versa, you're gonna have in terms of y if you are referring to the y-axis, like this. I mean the y point or the x point. Alright, it's important for you to know how to sketch the diagram so that you can get a more accurate idea about the whole thing. So for the one about the curve and the x-axis, you will have positive value when it's up here, or the whole thing here is positive. Alright, and the bottom here you get a negative value. So since area can't be negative, for this kind of graph where you have integral of fx dx, for the bottom here you're going to have a modulus for it so that you don't get any negative answer. The same thing goes for the y-axis. So what you're going to have is, on the right hand side, all it's gonna be positive, and on the left hand side all is gonna be negative. In other words, if you have something on the right, so your area is gonna be in terms of y and it's gonna be positive right away, or if it's on the left, this side, so you're gonna put a modulus so that you don't get negative for it. Alright, let's look at our first example for today. So you have this curve and they ask you to find the area between the curve and x-axis. So you have to know how to sketch the curve. This is obviously a cubic curve, so you're gonna have the first root is 0, second one is 2, and the third one is 5. Alright, since it's a curve between x-axis and the curve, and there's only one curve, so you have to determine which one is positive and which one is negative. So I told you, above the x-axis is all the positive one, and this is below the x-axis, so it's negative. In other words, you cannot do straight away from 0 to 5 for your limit to find the area, but you have to separate into two cases because this is positive and this is negative. Okay, I'm gonna put it down in the mathematical way. The area it's gonna be for this first part is from 0 to 2. The fx, I'm just gonna copy out in. Alright, plus this one. So it's going to be 2 to 5, and the same curve, but it's gonna be negative, right? So we have to put a modulus for this. Alright, so this is some simple integration. So I'm just gonna expand it into this one. Alright, plus the modulus of 2 to 5, the same function. Okay, I believe you can expand it on your own. And then we're gonna integrate one by one. So you have x to the power of 4 over 4 minus 7x cubed over 3 plus 5x squared, because 10 is gonna divide by 2. So the limit is from 0 to 2, close bracket, plus the modulus of same function minus 7x cubed over 3 plus 5x squared from 2 to 5 modulus. Alright, so you have to show your substitution in order to get the marks. Put in the 2 here, 2 to the power of 4 over 4 minus 7, 2 cubed, 3 plus 5, 2 squared, and then minus 0, because for whatever you put in here, it's gonna be 0, right? Be careful, it's not gonna be 0 for all the cases, because let's say e to the power of 0 is 1. Alright, here it's the same thing. So you're just gonna put in 5 to the power of 4 over 4 minus 7, 5, 3 over 3 plus 5, 5 squared, close bracket, minus, substitute 2, 4, 4 minus 7, 2, 3 over 3 plus 5, 2 squared, close bracket, and the modulus. Alright, so you can calculate all this using calculator after you show the substitution. You cannot straight away use calculator without showing this step. Alright, you must show the substitution. So after that, you can get 16 over 4 minus 56 over 3 plus 20 for the first part. Right, plus modulus 625 over 4, 875 over 3 minus, was it a plus? Yeah, plus 125 for the first part, minus the same thing here, because it's exactly the same substitution, right? 56 over 3 plus 20, close bracket, modulus. Then you can check the calculator. Remember, for whatever value you get here, you're going to get positive because of the modulus. Alright, and add with the first one. So I'm going to get 21, 1 over 12 unit squared. And that's it. Okay, so I repeat. What you're going to do is you need to know how to sketch the diagram. And you need to check whether it's positive or negative. If it's a negative, means it's under x-axis region, so you have to put modulus. If not, your area will cancel out and you won't get the same answer. So for the following example, I'm going to show you the other case where you have, just now we did this one, right? So we're going to do this case right now with the y-axis. So coming to this example, says this curve with this limit. So from last semester, you're gonna know how to sketch this curve. This is the horizontal asymptote here, alright? And 1 over x is this shape, okay? So if you forget about it, you should do your revision soon. So I'm gonna check here, and this is gonna be positive because it's on the right. And this is gonna be negative because it's on the left. Remember, we're talking about y-axis, right? So we're not going to combine this straight away because it's positive and negative. So we still still have to put modulus for the case. So the area it's gonna be, for a positive one is rather easy, 3 to 5. But this, it's function in terms of x, but we need to have in terms of y. So we have to change this function. In other words, we have to change it into y minus 2 equals to 1 over x, and x is gonna be 1 over y minus 2. You have to rewrite the function in terms of y. So putting it in here, you're gonna have 1 over y minus 2 dy. Are you okay so far? Are you catching up? Alright. So plus the other one is negative 2 to 1. Same thing. 1 over y minus 2 dy. But we're getting negative, right? So we have to put modulus. Alright. For this one is rather easy because above is just a number and the denominator is linear. So you're gonna get ln y minus 2, remember it's modulus, from 3 to 5. And this is of the same thing, so y minus 2, the limits from negative 2 to 1, close bracket, and the modulus. So you have to remember to show the substitution. So ln 5 minus 2 minus ln 3 minus 2. This is for the first part. Plus the modulus ln 1 minus 2 minus ln minus 2 minus 2. Okay? So you're going to have ln 3 minus ln 1. Ln 1 is 0, right? Plus this one, you're gonna have ln 1 minus 2 is negative 1, but with the modulus, we're gonna have ln 1 minus ln negative 4. So this one goes to 0, this one goes to 0. And we're gonna have ln 3 plus modulus of negative ln 4. And the modulus will give you positive. So you're gonna have ln 3 plus ln 4, which is ln 12. You can leave your answer like this or in decimal places. So the calculator will give ln 12 as 2.485 to 3 decimal places. Alright. If the question asks for exact answer, you're gonna stop here. Alright. This is not exact answer, but this is exact answer. Okay, so we're gonna continue with another example which involves two curves. So find the area bounded by this curve and this line or curve. So the first thing you know is you would like to know how to sketch this two diagram in order to get a better picture. Okay, so after I sketch it, this is what you have. This is for the curve y squared equals to x plus 2, and this is for the line. So the area bounded is actually this one. What we're gonna do here now is that we have to find the intersection point here and here. But another thing to our concern is that if we were to find the x coordinate, what we're gonna get here is this one and this one. Okay, so what we have is actually this area only, in which we will kind of ignore this one and you would have to find another area of this side. So finding the x coordinate is not really a good idea. Maybe you don't understand what I'm talking about, so I will sketch another thing for you to see. If you say for this curve, if you refer to the x coordinate, so what you're gonna get is between these two things. Alright, so if you say between these two things, this one, the area under this curve is gonna be this one. The whole thing until the bottom. Alright, and the area under this line will be all this thing. So when you use the curve to minus the line, what you actually get is only this one. And you are letting go of this. So the better way to do is actually you're referring to the y-axis instead. What I'm trying to do here is, if you refer to the y-axis, it's the same as you're referring to this one and this one. The y coordinate, I would say. So what you're gonna get here is, you're gonna find all the area under this line, and then you're gonna find all the area under this curve. And when you minus them, what you're gonna left with is only this one, which is exactly what you want. Alright? So what we're gonna do is we're gonna refer to the y-axis here. Alright? So first we have to find the intersection point in order for us to continue. Can you still remember how to find the intersection point? So it's by equating both equations. So you're gonna have, first one is this one, and the second one is actually y equals to square root of x plus 2, and you equate both of them. Alright, so x squared is equals to x plus 2, x squared minus x minus 2 equals to 0, x minus 2, x plus 1 equals to 0. So what you have is x equals to -1 and x equals to 2. So this point, it's our -1, and this point is it's 2. But since y equals to x, so y equals to -1 and y equals to 2. This point, it's -1, and at this point is 2. In other words, what we're gonna do now is we'll use the top one to minus the bottom one. Or in other words, we will say jauh tolak dekat. This is the further one. Alright, so looking for the area. Okay, what we're gonna do is, the area is actually equals to the limit from -1 to 2, because it's from the bottom to the top, and the top one would be x. I'm sorry, it's not x, because what we're referring to is the y-axis, right? So we have to refer to y. So it's gonna be y. Alright, minus, what we're gonna refer to is this one, but we have to find x equals to y squared minus 2. Bracket y squared minus 2 dy. Why would I say it's y and not x? It's because we are referring to the y-axis right now, and whenever we're referring to the y-axis, we will use dy. And it's impossible for you to integrate x in terms of dy, because yeah, it would be ridiculous. So you have to find y. That's how I remember it. Okay, quickly go through this integration. So it's y minus y squared plus 2 dy, and this is some simple integration. So I'm just gonna do y squared over 2 minus y cubed over 3 plus 2y. The integral from -1 to 2. So you're just gonna put in all the value. Alright, plus 2, 2. It's important for you to show the substitution. Minus -1 squared over 2 minus -1 cubed over 3 plus 2 -1 close bracket. And I'm gonna get 3 1 over 3 plus 1 1 over 6, which is actually 9 over 2 unit squared, and that's it. So for this case, we're referring to the y coordinate, that's why we're using dy. In a case where if you're referring to the x coordinate, then you would have to do dx, and this is always gonna be x. Alright?